All right, in this lesson, we are going to talk about ellipses, and they are very similar to circles, only you'll notice from the pictures that they are not perfectly round. And so we have some new vocabulary that we have to talk about, and that will be important as you start doing these problems. And so the first thing I want to talk about is the vertices. For each ellipse, you're going to have a vertex on each side of what is called the major axis. And so for a horizontal ellipse, the major axis is going to be longer in the horizontal direction, whereas for a vertical ellipse, the major axis is going to be a vertical axis. So major axis is always the bigger axis, and the vertices always lie on the ends of those. And so the shorter axis is called the minor axis, and then the points on each side are called the co-vertices. And so when we are talking about the distance from center to vertex or center to co-vertex, we use letters. And so from center to vertex, whether it is a horizontal direction or a vertical direction, is A. So it's kind of like your radius in the longer direction, your longer radius. And then your shorter radius will be your B value. Okay, and so A will always be the length from center to vertex. B will always be the length from center to co-vertex. And so this is always going to correspond to the major axis. And so the length of your major axis is just going to be twice the A value. The length of your minor axis is always going to be twice your B value. Okay, and notice from our equations, it looks very similar to a circle. We have the x minus h squared, and we have the y minus k squared. That's going to tell us our center. And so the difference is now it is always equal to 1, and we have these coefficients in the denominator. And so the value under your x is always going to be your horizontal distance, your horizontal radius, if you want to call it a radius. And then the number under y is always going to give you the vertical radius, regardless of whichever one is bigger. Okay, and so of course you're going to take the square root of those because that says a squared, that says b squared. Okay, and so here a squared, a is always going to be your bigger value because it's your distance to the vertex, which will always be the major axis. And so here for a vertical, your a is under the y. Okay, and so the last thing we need to talk about is the foci. And so we have two foci, one on each side, and they always lie along the major axis, and they're going to be inside the vertices. Okay, and so the distance from center to focus is going to be what we call C. And that's really only helpful if we're missing A or B. We'll use the C value to help us find that. And so in this case, your C is length from center to focus, and it's always going to be on the major axis. And then we have this equation that will help us get A and B if we don't have one or the other. All right, so let's jump into some examples so that we can get a more concrete understanding of this. And so looking at number 1, I see that this is a horizontal ellipse, and the center is right at the origin, 0, 0. Okay, and then my major axis is a horizontal line, and so this is a horizontal ellipse. And so my A value, distance to the vertex from center, is 6. So our A value is 6. That's going to be our horizontal distance, or our horizontal radius. And then our vertical radius is our B value of 2. And so that's all we need to write our equations. Since the center is 0, 0, you're just going to see an x squared and a y squared. So I always do fraction bar plus fraction bar equals 1 for an ellipse. And then the horizontal distance was 6, the horizontal radius. And so that means we're going to have a 36 under the x. And then my vertical distance was 2. And so I'm going to have a 4. You always square those values for your equation. Okay, so in this next one, we're going to look at one that isn't centered at the origin. And so just kind of trying to eyeball it, then draw in the major axis. Okay, and so we'll see if I drew it in the right place. And so 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I did good. And so our A value here is 9, and it's running in the vertical direction this time. This is a vertical ellipse. And then my center is -3, +5. And then our B value is going to be the horizontal radius, which looks like 1, 2, 3, 4. Okay, and so for our equation, I do fraction bar plus fraction bar equals 1. Then do your parentheses squared. And so my center is at x equals -3, so I'm going to see an x plus 3 inside the parentheses, and then a y minus 5 for the y coordinate. Okay, and then looking back at the picture, my horizontal radius, that's always going to go under your x, regardless of whether it's A or B. And so my horizontal radius this time was 4, and so I'm going to have a 16 under the x term, and then under the y term, that radius was 9, so I'm going to have an 81 underneath the y term. Okay, in these next examples, we are going to be given the equation, and now we have to create the graph. So I like to start with the center. And so here there's nothing with x, and so the x coordinate is 0. The y coordinate is +4. And then A is always going to be the larger value, and so there is a 36 and a 4. So our A value is going to be the square root of 36, which is 6. And then our B value is going to be the square root of 4, which is 2. And so let's go ahead and start getting this on the graph. And so the center at 0, 4. And then my horizontal distance was the 2. Always look for the x term to see your horizontal distance. And so we're going to go 2 to the right and 2 to the left. Our vertical distance was 6, looking at what is under the y. And so we're going to go up 6 and down 6. So 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. Okay, so now that I have the vertices and the co-vertices, we can go ahead and label those. So the vertices are red. Those are always along the major axis. And so we have 0, 10, and 0, -2. And then the co-vertices are in blue. Those are always along the minor axis. And so those coordinates are -2, 4, and +2, 4. Okay, and so once you have those vertices and co-vertices, you can go ahead and connect them to create your ellipse, just the best you can. And then we can go ahead and skip to domain and range. And so the domain is running from left to right, and so from co-vertex to co-vertex. That is -2 to +2. And we're going to use brackets just like with circles because we do actually have those points. And then for the range, we are running from bottom to top. And so vertex to vertex, -2 to 10, again in brackets. Okay, and so the last part is probably the most challenging. It's finding the foci, and for that we need to use the C value. Okay, and so we have an equation from the first page is C² = A² - B². And so in this case, c squared equals a squared, which is 36, minus b squared, which is 4, which would give us a 32. And so our c value is square root of 32. And so to approximate a square root, just look for perfect squares that are above and below it. And so 32 falls between 25 and 36. And so that means the square root of 2 falls between 5 and 6. And so remember, they're always along the major axis. And so that 6, or the square root of 32, which is approximately, let's say 5.5. So that means we're going to go 5.5 units up from the center and 5.5 units down from the center to get the foci. So 1, 2, 3, 4, 5, and then so they're really close to the vertices. Okay, and so to write the coordinates of the foci, they are both on the y-axis, so they both have the same x-coordinate of 0. And then they start at the center, which was 4 for the y value. And then in one case, we added square root of 32. In the other case, we subtracted. So if you want, you can write it as one set of parentheses and just do a plus or minus square root of 32. Okay, looking at this next one, there's no denominator under the y, so when that is the case, there's an invisible 1, if you want to go ahead and write that in. Okay, and so starting with the center, I see a -2 for the x, so that means my x-coordinate is +2, a +5 with the y, and so that means -5 for the y-coordinate. A is always going to come from the bigger denominator, square root that, you get 3. And then b, square root the 1, you get 1. And so we can go ahead and graph the center at 2, -5. And then my horizontal distance comes from the x term. And so we're going to go left and right 3 units, that a value. And then our co-vertices are going to come from the number that's under the y. So we're going to go up 1 and down 1. Okay, and so go ahead and make my ellipse. And so my vertices are in red. So -1, -5. And then 5, -5. My co-vertices are in blue. So that is 2, -4 and 2, -6. And so we have everything we need to do the domain and range, so I'll go ahead and do that. So my domain from left to right is running from vertex to vertex this time. And so -1 to +5 in brackets. We do have those points. And then for the range, we're running from bottom to top, so -6 to -4. All right, so now for the foci, we need to get the c value using our equation. C squared equals a squared minus b squared. A squared was 9, b squared was 1. And so we get c equals the square root of 8. And so square root of 8 falls between square root of 9 and square root of 4, so somewhere between 2 and 3. And so along the major axis, we're going to go between 2 and 3 to the right, between 2 and 3 to the left. Okay, and so you can leave it as just square root of 8. You don't have to simplify your radicals. And so to write the coordinates, we are going to have the same y value this time at -5. So I'm going to go ahead and put in that y value. And then our x value starts at 2, and then we subtract the square root of 8, and we added square root of 8. And so starting at 2 plus or minus square root of 8. Okay, for these last two, they're giving us some information, and we have to write the equation and do the domain and range. And so for number 5, they're telling me the co-vertices, that's the minor axis, are negative 12, 0 and 12, 0. So be careful on this one. The axes are going by 2. And so negative 12 and positive 12, those are my co-vertices. So that means this is my minor axis. And the center will be right at the midpoint. So it looks like our center is 0, 0. And the other piece of information we get from this is our B value. B is always to co-vertex. So my B value is 12. Okay, the other information they give us are the foci. So we have 0, 5 and 0, negative 5. And so remember, this is going by 2s. So 5 would be about there. And then negative 5 would be about there. They always lie along the major axis. And so that tells me my C value. C always goes with the foci. And so my C value is a distance of 5. So we know B is 12 and C is 5. And so in order to write our equation, we need the A value. And so just filling in what we have so far, because our center is 0, 0, we're going to have an x squared and a y squared all by themselves, no parentheses, equal to 1. And then we have the horizontal distance. It's our B value. And so we're going to have a 144 underneath the x squared. And so as soon as we find the A value, we can put A squared here. And so that's where we need to use our equation, C squared equals A squared minus B squared. C squared we know will be 25. A squared is unknown. B squared will be 144. So we're going to add 144 to both sides to get 169 equals A squared. And so remember, A squared is what shows up in the equation. So that's what we'll need to write underneath the y. And then if we want the true A value, we just square root that and get A equals 13. And so 13 would fall about there and about there. Oh, no, that's not right. That's negative 13 right here. And so you don't have to do that, but it's helpful when you're writing your domain and range. And so my domain is running from co-vertex to co-vertex, which is negative 12 to 12. And then my range is running from negative 13 to positive 13. Okay, last one, vertices at negative 8, 2. So negative 8 would be right here, and then 2. And then 2, 2. Those are my co-vertices. And so the center is going to be the midpoint of that. And so if you draw in your major axis, you can count, or you can add up negative 8 plus 2 and divide by 2 to figure out where the midpoint is. And so that's negative 3 if you don't like counting. So my center is negative 3, positive 2. And we also get the A value from this. And so my A value is a distance of 1, 2, 3, 4, 5. Okay, and so we can start writing our equation with what we have. Our center has an x-coordinate of negative 3, so x plus 3 squared. My y-coordinate is 2, so y minus 2 squared always equals 1. And then I know my horizontal distance is 5, so I am going to have a 25 underneath the x term. For the y, we need to find the B value. So they give us the foci again, which are negative 7, 2, and 1, 2. And so that is a distance of 4 away. And so we have a C value of 4. We have an A value of 5. So we can use our equation to find our B value. Okay, and so the equation says C squared equals A squared minus B squared. C squared is 16, A squared is 25. Subtract 25 from both sides. I believe that is -9. And then divide both sides by -1. So b squared equals 9. We can fill in the 9. And then we also know our b value would then be 3. And so up 3 and down 3, that'll help us find our range. So you can make your ellipse. Oh, that wasn't good. Make your ellipse. And so the range is running from -1 to +5. And my domain from left to right is running from -8 to +2.